So for this first one, it's quite an interesting question. They said also a bit difficult at times because you couldn't really tell. You have to kind of guess how old, like you have to compare like older people with younger people. I suppose that's an old person, yes, and a very young guy. So that's what I think. So they were saying here, if this is a graph, we are comparing age and height. And they've given us this list of people. And Gavin, it took me a while to realize that Gavin is a baby there that is being held by that person. I was like, is it a dog? Is it a ghost? What is this? But it's actually pointing towards a baby over there. So can we all agree that Gavin is number 7?
Yes.
That was, I think, the easiest one to find, right? Because Gavin, number 7, is the youngest. So on the age axis, he's lowest. And then also, obviously, the shortest, okay, because he's a baby. So number 7 was Gavin. So this one was a bit easier to do if you kind of went from the two extremes. So you went from the youngest and the shortest, and then you looked at like the oldest people. So we'll talk about that now. So next up, number 6, I said was Kathy. Right, do you guys agree? Because Kathy is a young girl, I suppose, right? So Kathy would be second oldest and also, second oldest there, and also, or second youngest, my apologies, and then also the second shortest, all right, out of this list of people. So that's fine, Gavin, Kathy. All right, then I looked at those two top points there, 1 and 2. Do we agree that those two people have the same age? Right, because if we look on the age axis, they are both in line. All right, they both have the same age here. So if we're looking at this list of people or this group here, who do we think have the same age? Dennis looks, because this is also the oldest, all right? So these would be the oldest people, the two oldest people. What do you guys think? So Dennis is definitely one of them. Okay.
I think Dennis would be 1 and Frida would be 2.
So are we saying Frida or Alice possibly? I actually think I said Alice, but let's just check. Dennis would be 1. I agree with that because he is the oldest, but then he's also quite short.
Oh, yeah, no, sorry. I didn't mean to say Frida. I think Frida's 3.
Yes, I also thought so, but we can just check that now. Okay, it might be, we could possibly swap the 2 around. Let's just check. Are we fine with Dennis being number 1? Because he is the oldest, but if we're looking at the fact that there are 2 people here that are the same age, Dennis would have to be the shorter one of the 2, because on the height axis, he is before number 2. Okay, so this one is Dennis, number 1. Then what can help us to decide whether Frida or Alice will be number 2 is if we look here, that 2 and then someone else would have to be the exact same height. All right, now is there someone else that is the same height as Frida? No. But is there someone else that's the same height as Alice?
No.
Yes, Errol is the same height as Alice. All right, so that can help us if we then say that Alice is 2, because she is the oldest, all right, the same age as Dennis, we can assume. But then Alice is much taller than Dennis. All right, so Alice would have to be number 2. Then in the same breath, we can see here that if Alice is number 2, the other person with the same height as Alice would be number 5, right? But obviously younger. So that would be Errol. So Errol is number 5. And then we now have to decide between Brenda and Kathy. Who is 4 and who is 3? All right, so I said that, sorry, Brenda and Frida. Sorry, I said Kathy, it's actually Frida, this one here. I said that Frida is number 3 because she is in between heights. If we look at 1 and 2, right? 1 is Dennis, 2 is Alice, Frida is kind of in between the 2, which we can see here for the height also. And if we're looking at 3 and 4, which one do you guys think is older, Frida or Brenda?
Frida.
Frida is older, so Frida has to be higher on the age axis than Brenda. All right, so Frida will be number 3 and Brenda will be 4. Okay, so they say justify your answer. I tried to write some stuff down. It's not exactly the same as what I said now because we've discussed other things, but I just wrote that list 1, 2, 7. Oh, sorry. And then I just kind of filled them in as I figured them out. All right, so I filled in Gavin first. He is the youngest and the shortest. Then I filled in Kathy. She is the second youngest and only taller than Gavin. Or you could say the second shortest, whatever your justification doesn't have to be exactly the same as mine. All right. And here I also haven't actually written something for Frida yet, number 3. So we'll do that now. Then for 1 and 2, I said that 1 is Dennis and 2 is Alice. They have the same age, but Dennis is shorter than Alice. And we could add here that Alice is the same height as number 5. All right, but no, that's fine. Then for Frida, what did I do here to figure out that Frida was number 3? She is her height, I suppose, is in between Alice and Dennis's height. Okay, that's one thing that I'll say because number 3 was almost like in between 1 and 2, like that. So yeah, just something to kind of explain how you decided which point is which person. Yeah, but that was quite interesting, right? Doing a bit of a problem solving kind of thing there. All right, do you have any questions on 1.1? 1.2. So you can just see what I wrote there and just let me know if you disagree. Let's just look at them from the top. So they gave us 3 graphs describing aircrafts A and B. And the 3 graphs are comparing different things. So for the first one, they're saying that cost is over here. So do we all agree that B is more expensive than A? But then if we're looking at age, A is older than B, right? So what is this graph telling us? The older aircraft, A, is cheaper than the newer one, all right, which is B. For this one, they're comparing size and cruising speed. So if we're looking at size, we can see that B is bigger than A. And then also cruising speed, B is also faster than A. All right, does that make sense, guys? For this last one, not sure, what is range? What does that mean? How far it can travel? On what? On a tank in its lifetime. Anyways, okay. All right, so range, how far it can travel, thank you, versus passenger capacity. Okay, so this is not obviously how many passengers it can carry. So B has the bigger capacity, but A can travel further, has the bigger range. All right. Now they're asking us some questions. 1.2.1, the first graph shows that aircraft B is more expensive than aircraft A. What else does it say? Just hold on. We said that B has a higher cost than A. It's more expensive than A. Yes, Joseph?
I wanted to say that it's newer, so it has like it's more clean inside.
Yeah. Okay. So we can guess that it would be more clean, but what we need to talk about is the age. Okay, which is fine. So B is newer than A, or you could say A is older than B. All right. You could describe it in both directions. So I said here, aircraft A is older than aircraft B, or you can say aircraft B is newer or younger. I suppose newer is a better word there to use than aircraft A. All right. It's fine if you wrote it the other way around. For 1.2.2a, they're saying here now, are the following statements true or false? Justify your answers. So even if you're just saying true, you have to also justify, which is a bit annoying, but anyway. The older aircraft is cheaper. All right, so now we're looking at this first graph again, because this is the one that is comparing age and cost. The older aircraft is A. Is A cheaper than the other one? If we're looking at this graph, because that's what they're saying, right? They're saying the older aircraft, which is aircraft A, is cheaper than aircraft B. Is that true, guys? If we're looking at cost, which one is lower? Which one has a lower cost? A, all right? B has a lower age, but B has a higher cost. All right, so the older aircraft A is in fact cheaper. All right, so that's just what I wrote there. I said true, aircraft A is older and cheaper than aircraft B. It's basically just, yeah, it would be 2 marks, I'm sure, yeah. Okay, for B, the faster aircraft is smaller. So now we're looking at the second graph. The second graph is comparing size and cruising speed. So they're saying the faster aircraft, which one is faster? If we're looking at cruising speed, which one has a higher cruising speed? B. Now they're saying that B is smaller. Is that true? If we're looking at size, B is actually bigger than A. All right, so what they've said here is false, because the faster aircraft B is bigger, not smaller. All right, let me just check what did I write. False, aircraft B is faster and larger than aircraft A. Okay, so it's bigger, it's larger, it's not smaller, which is what they said in that sentence. Then I left out C. This is what Cameron just pointed out yesterday. The wording is strange there because they're saying the larger aircraft is smaller, which doesn't make sense. So I think if you wanted to answer that, you could have said false. Obviously, the larger aircraft is not smaller. So you could have said false, the larger aircraft is larger. I don't know, but I think that must have been a typo or something. So I left it out, but it's okay if you just said false for C, but the sentence there doesn't actually make sense. I think they were wanting to ask something else, but I'm not sure what. All right, for D, the cheaper aircraft carries fewer passengers. Now, guys, is there a graph that compares cost and passenger capacity? No, hey? So we actually need to look at 2 graphs and kind of put that together. So this one was a bit more difficult. So let's see. They're talking about the cheaper aircraft. Which one is cheaper? Let's just look again at the one with cost. The cheaper aircraft is A. So now let's check. What are they saying? They're saying that A carries fewer passengers. Let's see. Is that true? Let's go to passenger capacity. Does A have a lower passenger capacity than B? Yes. Okay, so that is actually true. So true, aircraft A is cheaper and has a smaller passenger capacity than aircraft B. All right, so you actually had to look at 2 separate graphs and put that together. So that was quite difficult, that one. Okay, we'll look at 1.2.3 now. I just want to make sure that you guys have copied all of that down. 1.2.3 was the real tricky part where you had to combine information from separate graphs onto your own graph. So we'll look at that now, and I hope I did it correctly. Okay. Mark and label 2 points to represent A and B on each of the last 2 graphs above. So these 2 graphs, they want us to put an A and a B down on both of these graphs. So let's look at what they are comparing here. Age and cruising speed, which is actually that and that we now have to compare. So what I did was, first I just looked at which of these 2 aircrafts is the older one, because then I know that that point has to be higher up than the other one. Okay, so which one is older here? If we look at A and B, which one is further? Which one has a bigger age value here? A. So A is older, so it doesn't make sense that A is going to have to be higher up than B, because now age is on the y-axis, right? So now I have to put it higher than B. But now it also has to match this one. So cruising speed, let's see, cruising speed is over here. Which one has a higher cruising speed? B. So A has to be above B but B has to have a bigger cruising speed. So B has to be further along the x-axis. So just check, guys, they don't have to be in those exact same spots. Just make sure that A is on the top right. Sorry, top left. This is left, my bad. Top left, all right, of your graph. And B must then be bottom right. Okay, so that A is both older and slower than B. Okay, it's difficult to do that. That was a tricky question. Any questions on that one? All right, then the last one was size and range. So again, because size is the y value, the y-axis, I looked at which one must be higher than the other one. So which one is bigger? So let's look at size. Oh, flip. I messed it up. B and A must be swapped around. Yes. Oh, no. Okay, so there we go. Let's see. I hope the points are in the right spots. We'll see now. Okay, definitely B is bigger than A. Do we see that? Right? Because this is size. B is further on the size axis than A. So that means that B is bigger than A. So B has to be at the top this time around. Okay, sorry. So B must be at the top. Now, what is the other thing that we're comparing? Range. You see that A has a higher range than B. Because we're looking at the Y values here now, right? So A will be higher up than B. So A has a higher range, meaning that A has to be further along this line than B. Okay, so does that work in this way? Hey, B is bigger, B is bigger than A, so it's above A, but A has a higher range than B, so A is further on than B. Okay. Right, guys, our time is basically up. I was going to give you guys another worksheet. I'll just hand that out now quickly. And I want you to start working on this next worksheet, but basically you're going to work on it in class on Monday, okay, when I'm not with you, when you guys are with Mrs. Court. The questions are quite difficult though. The first one is you'll see real life graphs. And it is, yeah, it's you're gonna have to use your brains for that one. So we have until Tuesday to work on these worksheets all of them. So we'll still chat about something on Tuesday, and we also have to mark the rest of that graph how it's moving. Guys, the front of the page is the one that starts with real life graphs. Okay, that is the first one that we're going to do. Okay, guys, so looking at that first thing that says real life graphs, all look at that page, please. It says the water is poured at a constant rate into each of the following beakers. All right, so each of those shapes that actually represents a beaker, like a container that you are pouring water into. Now they're saying 4 graphs are shown below, so they've given you those 4 graphs, and on those graphs they are comparing the depth of the water as time passes. Right, so depth of water versus time for all of them. For 1A, they're saying draw the graphs in your book. Okay, so you're just going to copy these 4 graphs in your book. It doesn't have to be exactly perfect. Don't worry, just try and get the shape similar. Next to each, draw the beaker that it represents. Now, guys, if we are looking at a beaker, do we have one of those? We're looking at G. Look at the shape of G quickly. Right, it's narrow at the bottom and then it becomes wider. So what do you think is going to happen to the depth of the water? Hold on, I just want to give everyone a chance to think of it. As you are pouring water into this thing, and they're saying at a constant rate. Okay, so you can't say, oh, but are you not going to pour it faster? Okay, it's constant. They're saying depth of water. So if you had like actual measurements on the side here, right? If you actually split that up into like notches that were equal, that is the depth. Okay, they're talking about how is the depth of the water increasing. Now, if you are pouring water into something that is narrow at the beginning, isn't that depth going to increase quite fast at the beginning because it's narrow, right? Then as it gets wider and wider and wider, even though you're still pouring the same amount of water in, the actual increase of the depth is going to become a bit slower. Okay, do you guys understand what I'm saying? So is there a graph on there that you think would represent that? Where we have a big increase in the beginning and then it becomes a bit slower afterwards, slower after a while.
No, I don't think it would be any of those because in my eyes, the G would go like this.
Yes, good. Okay, what do we think? So it would increase a lot first and then it would kind of slow down. So the graph for G, if you have this thing, right, those are your axes, will actually look like that. Right, does that make sense? So the depth is increasing a lot at the beginning because it's a narrow thing. Right, so you need to pour less water in for the height to increase, or the depth rather, to increase quickly. So that will be the beginning part while it's narrow. Then as it's getting wider, the actual depth of the water will increase slower, at a slower rate. So that would be the graph for G. Okay, now this is the opposite of that. Can you see? B. Right, if we look at this is increasing very slowly at the beginning, and then all of a sudden it increases quickly. Right, do we see that? Because this is the depth. Okay, so the depth is increasing slowly, slowly, slowly. It's getting faster, there it's increasing very quickly. So this is the graph for B. Okay. You're going to have to figure out the others. All right, guys, on Monday, when you are with Mrs. Court, I want you to start working on this worksheet. You have to finish the real life graphs part, but if you're done with that in the half hour, then you carry on working. Okay, so this is going to be the cut off for homework for Tuesday. All right. Thank you, grade 8. You can go. Have a lovely weekend. I'll see you all on Tuesday.